Hey, calculus class. Here I am. Missed you guys a lot. The fact is the past 3 weeks have been very challenging, mentally, emotionally. Just understanding that who knows what the future looks like with us being able to engage in class on a daily basis. So know that I missed you. I had to try to decide how I deliver information to you. I've decided I'm going to deliver it this way. So I have a dry erase board here. I've got you in my house. I'll give you a tour of the house later. But this is where I'm at. And I figured if you saw me, not that I have anything good to look at, but just figure it would provide a little bit of humanity between you and the learning. And so hopefully we can figure that out. Good news for you guys. We have 3 really good quarters so far in mathematics. So there's a lot of really good content you've gotten through. We are not going to do all fourth quarter. We're going to do just the most important parts. We're going to make sure that we're reviewing those important parts for you at the beginning. So, for example, I'm going to start off with area between two curves. That's something that you saw before we left for spring break. We're going to make sure you can see that again so you don't forget. Your homework, make sure you check out that DOM equation editor so you can figure out how to type your responses using mathematical notation. And also, just make sure if you need help at any time, you reach out to me. We can sit down on a Google Meet, be able to view each other face to face and do problems on the board together. It's no problem at all for me to do that. So I'll look forward to that piece to be able to work that through with you. So anyway, here we go. I'll throw a fun video in from time to time, but just so we can make sure we get going. We want to be able to look at 2 examples today. We want to be able to find area between 2 curves. In this case, we have y is equal to 7 minus x squared and y equals x squared minus 1. If we take a look at those graphs, 7 minus x squared is going to look like this. And x squared minus 1 is going to look like that. Okay? And important to take these notes down. I know you're kind of taking them by hand, but just know that your tests, you'll have 2 of them during fourth quarter, they will be open note, they'll be open review, they'll be open the resources that we have. They're not open internet, open phone, and not open person. So I don't want to sit down and do those together. But this is what we had. If you remember, we look at drawing a rectangle here to be able to find area. Notice that it's a vertical rectangle, and it has what we call horizontal width. It has width of what we call dx. Dx is our width in that situation. And we like to look at our the height of the rectangle as the top minus the bottom. So the height of one rectangle is going to be, the top one is 7 minus x squared, and we're going to subtract x squared minus 1. And as you subtract those, 7 minus negative 1 is 8, and negative x squared minus x squared is negative 2x squared, and that's going to be times dx is going to be the area of one of the rectangles. We don't want area just one, we want an infinite number of them. So I'm going to look at an infinite number of rectangles by slapping on an integral. Now what I just need is I need to know my bounds of integration. And that's going to happen at the intersection point right here. So I'm going to look at the intersection between these two guys. When is 7 minus x squared equal to x squared minus 1? Well, if we add the x squared over and subtract the 7, we get 0 is equal to 2x squared minus 8. So we got 2x squared minus 8. Factor out the 2. And we've got x squared minus 4. That factors 0 equals 2 times x minus 2 times x plus 2. So we have values here of negative 2 and of positive 2. So you can go negative 2 to positive 2. But if you notice by looking at this that the area is symmetrical on either side of the y-axis. And because of that, you maybe remember one trick that we could do. We could simply just double the integral and go from 0 to 2 instead of negative 2 to 2. So 8 minus 2x squared dx. Now the problem becomes very simple. We simply just find the antiderivative of 8, which is 8x. The antiderivative of 2x squared which is 2x cubed divided by 3. We evaluate at 2 and 0, and we're going to go ahead and double that answer due to the 2 that we have up front. So we get 2 times, 8 times 2 is 16, and then 2 cubed is going to be 8 times 2 is 16, so 16 thirds. 16 in terms of thirds is 48 thirds, minus 16 thirds is 32 thirds, times 2 is 64 thirds. And that's the area bounded between those two curves. And again, that's a dx example. Next one we're going to look at, just like you probably thought, we're going to look at a dy situation here. So we have one of each. Hopefully you guys have gotten some exercise in. I know this weekend, actually right now is Sunday when I'm recording, so it's a little bit crummy outside, but I think we're supposed to get some decent weather coming up here, so make sure you try to get out and get some exercise in. We have x is equal to y squared, and we're also going to look at y is equal to 0, and then we're going to also look at none other than y is equal to the square root of 2 minus x. Okay, so this is a good example here. And if we just try to view our region appropriately, and that's really a key, is to be able to view that region that you're trying to find the area of appropriately. Because it's a little bit of a trick just understanding the graphs. Fortunately, you know that x equals y squared is a horizontal parabola that looks like that. And then y is equal to 0. Well, that's the x-axis, so that's this guy right here. Okay? And then y is equal to root of 2 minus x. Well, the square root function looks like that. It's shifted 2 units, and since it's a minus x, it goes the other way. So if I look at this guy, it's going to kind of head back that way. So the area that I'm looking at is this guy right there, okay? That's my area. Notice the challenge, though. If we were to draw a rectangle there, you can see that this guy is the one that sits on top. If we draw the rectangle here, then it's this guy is the one on top. And that becomes challenging. And so a better option in this situation is to go like this. We draw a sideways rectangle. And so since it has what we call vertical thickness, okay, we say it has dy for thickness. Instead of doing top minus bottom, we do right minus left. So the right function is the square root of 2 minus x. And the left function is y squared. Notice that since we're dy, that these must both be in terms of y. So this one's a y squared, so I'm going to go, this one is not okay. So I'm going to relook at this guy right over here. If I square both sides, I get y squared is equal to 2 minus x. Oh, not x squared. Y squared is equal to 2 minus x. I'm going to solve that for x. So if I add the x over, I get x is equal to, and subtract the y squared, get 2 minus my y squared. So that's my equation for this guy now. So my right becomes 2 minus y squared minus y squared. So that's the right minus the left, dy. Or 2 minus 2y squared dy. We want to do an infinite number of those. Okay, an infinite number. We just need that point of intersection. We need to know where they intersect. And again, we're looking for y values. We can see that the bottom here is going to be right at 0. And then the top here, we want to be able to figure out where that is. So we're wondering where is y squared equal to 2 minus y squared. You subtract the y squared over, you get 0 equals 2 minus 2y squared. Factor out the 2, 1 minus y squared. So you can see it's going to be positive 1, and it gives you a negative 1. It's technically on the bottom, but we don't have that negative 1. It's producing a solution that we don't really have. But the positive 1 on top, that's the one we really want. So we put the 1 right there. Antiderivative, we've got 2y minus 2y cubed over 3. Evaluated at 1 and at 0. Plug in the 1, I get 2 minus 2/3. And I've got 1/3 as my result. So there's area between two curves, dx and dy. Got both examples. We're going to keep it hopefully really straight forward for you guys with these lessons. This was a review. Next we're going to do washers, dx and dy. So hang in there. Miss you guys. Wish we were face-to-face. Hope we get back together soon. Stay safe, stay healthy, and just get some math done, okay? Have a good one.